Okay. So that's alignment. Vacuum. So we're started in high vacuum. I can change the VP right now, okay? So it's going to turn the beam off. You'll hear some valves changing, and then it shows your current vacuum here, and then the slider is where, so you asked earlier, how do I know what vacuum to set at? Always start at a better vacuum and then work your way down, okay? There's no particular, each sample is going to be a little different, but it's just, rule of thumb, start higher, lower number, and then increase it, and you'll watch in live time how the charging goes away. This is a stage tab. So another place to move our sample. So you notice in this one, I can just move X and Y. If I want to move, I can do tilt in my Z here and rotate. I'm going to show you an easier place to do that. Raster rotation. So raster rotation just electronically rotates what's on the screen. We're not physically rotating. So if I turn this on, so I'm just electronically, so say before I capture my image and I want to get it lined up nice and pretty so it looks more, better to the eye, you could just electronically rotate it on the screen without having to move the whole data display. So this is nice if I want to do a measurement. Okay, so if I want to do a quick measurement, what size of this particle is, I can do that. This is calibrated. You can trust these measurements. You can do an angle. You want to find the angle of something, or you want to put in some text. Okay. Now, and then if I click this guide, I can move the text around. You can change the color, the font, all the normal stuff. You can also do this afterwards. There's software in here that you can do this. You can do measurements, post-processing after the fact as well. Okay.
So, can we save the images after the measurement?
Can we save images after the measurement? Yes, you can save images after the measurement, but by doing that, it's going to be burned in that image. So if you're fine with it being permanent, yes. So whatever I have put on here before I capture will be in that image permanently.
What if you want to have a duplicate? First, this image without any write-up, and then we add the measurements, and then we save it again.
Yes, you can do that. You can take an image first, and then the exact same image, you can add the measurement and take it again.
Okay.
Or I can, so I captured this image earlier, right? If I click on it, I have the option to add it now. Okay.
You can save it again. A different part.
Yes. So I have a data entry here as well.
Okay.
So we have, yeah. And you can do an auto, you can change contrast here after the fact, whatever, right? So yeah, you have lots of options to, of how you want to do it. The image, this just shows a histogram of the live image right now. Okay, if I change. All right. So I'm going to kind of go over this window here. So this is our navigation, right? So as I move, so the red cross is our beam. So this is the beam hitting our sample. So I can zoom in and out of this map, or I can use the scroll wheel to zoom in and out. So you see the number 1 here? Every time we capture an image, it saves on our map where we captured that image. Okay? So if I come back to our captured images, highlight it, and then I hit on this cross, it will move back to where I took that first image. Okay? So you can navigate around, capture a bunch of images like, oh, I want to do EDS on that first image. Click on it, hit move, and you're right back to where you were. Even if you tilted, rotated, it'll go back to that same rotate and tilt where you selected that first image. So that's a nice feature. So you see here how there's a, look how that image looks like it's tilted, right? So now this represents where our sample is inside the column. Okay, so flat sample, I can grab it, move it up and down. If I grab the side, I can tilt. It hasn't done it yet, okay? So it's showing me at 12, I can tilt 37 degrees. But if I lower it, see how that number changed? So now I can tilt up to 86, okay? I have to hit move, and then it'll move, okay? So you can see, okay, how much do I need to drop it to be able to tilt? So we'll do that.
Are you happy?
So this is nice, so you can actually kind of see a representation of,
What happened?
and then this will change too, depending on how big size we put in. So you can actually see it tilting in there.
And then would it automatically come into focus, or we have to?
We either just hit autofocus up here, we'll do a good job. Or what's nice, if we have this selected, Z focus link, it will, if we're in focus at 10 and we drop it to 30, it'll change focus as we drop it down. Okay? So do auto brightness, auto focus. So that is next to, so this is our map. And then the map doesn't tilt, right? But this is the easiest way to tilt and change Z. So like I said, if we had focus link and then rotate, I'm going to show you the easiest way to rotate. So here is different mouse modes, okay? So if I click on this hand, I can use the hand to drag and move my sample, okay? Or if I click anywhere, it brings that to the center of the screen. So that is this hand. Now this is our horizontal stage, okay? So say I want to get this grid perfect, you know, nice and lined up horizontally. I can grab this little dumbbell, drag it, and snap it. Snap a line on anything that I want to make horizontal. So that to me is the easiest way to rotate. Here, just by holding this down, but that's going to rotate on the center axis, right? That's slow. I can type in a value. I can type in a value. Gonna make a liar out of me. Oh, sorry. you type in a value, and then you select, do you want it to go 60 plus or 60 minus? So you type in a value and then hit which way you want it to rotate, okay? When you tilt your sample, you want to make sure it's secured right on. You don't want to just set it on there because it'll slide off. Yeah, tape over it. Yeah, so it's held on securely, definitely. So, like I said, this is nice because you can tilt and change your Z. You don't have to worry about hitting anything, and then you know, okay, I need to tilt 90 degrees. I need to drop it so much. So, and then you also have negative tilt as well. So, when you load the sample, I should have pointed this out. This is north. This is north.
Oh, okay.
Okay.
So when you load the sample, this is the top of the screen. Okay? This is the top. And when we tilted, we're tilting in this direction, right? Why do we do that? Because our detector's here. We want to tilt in line with the detector. So we're pointing at our sample
Maybe
at
you
all
should
times.
make a note there, just it's not over there, just
With a
so-
marker.
Yeah.
like a marker.
And yeah.
Yeah. Otherwise,
Yeah. So it just, I mean, you can always rotate your sample when it's in there, but it's just, you know, if once you load it, you have a frame of reference, you know. So this is our camera, so we can see what's inside. We can actually, there's a chamber scope, so we can actually see our sample that's in there. Okay? And you can actually zoom in on this and move it around as well. So this is our EDS detector. So you see everything is above. Okay, so we're not going to hit anything. This right here is our backscatter, very thin backscatter detector. So if we come back here, move it up, hit move, we can actually watch it. You can actually see what's going on. It's still nerve-wracking watching that, right? Woo!
Is it too close?
No.
what did you do? I missed that.
I moved it and hit move and then just went back to the camera so we could watch it move in there.
But does it have any internal sensors to not have it pump? Because it's already
The camera? No, it's
not the camera, but
The sensor.
yeah,
The
sensors. Yeah. So it
yeah.
doesn't
When we loaded our sample, then we set those parameters that we weren't going to hit anything. Yes. The question is, we cannot move it below that. Normally, no. There is an option, and I'll show you, but I recommend don't ever using it. It's called free mode.
So don't show that. Don't show that.
Don't show that. Okay.
Yeah.
So that's called free mode. But to go into free mode, it's like disclaimers. You actually have to click and say, okay, you know, if there's any damage, like it tells you. So normally we're not in free mode. It's all when we load the sample, and that's why we had that height gauge there, because it's going to keep it from going any higher. Okay. Yeah.
Yeah.
You don't want to do that. All right.
So you took it back to 10?
So right now we're at 6.5. So we're actually close. We're almost as close as we can get. So look, I can only get to 5.
Oh, okay.
5 is
Allow us to go beyond that.
exactly. And that's what we set when we loaded it. That was the 5.
So it's a safety setup.
Yeah.
Safety, yes. To change detectors, so right now it's telling us we're using our secondary, right? This pull down is how we change detectors. UVD, backscatter. Okay. So very simple to change detectors. So the backscatter has different modes. You asked, can we look at two detectors at the same time? Yes. So I clicked here. So this is single screen, now dual screen, okay? And I can look at a backscatter and secondary at the same time. So whatever screen I have, that's my active screen. So 1 or 2, so I want to make this one active.
The secondary looks like it has better contrast, right?
Ye-
Backscatter.
Yes, because I'm at a smaller spot size. So let me go to larger. Now it's fairly similar, right? So you can see with this sample, there's not much difference between the backscatter and the.
So which one you suggest to use?
Whichever one gives you the information you're looking for. So it's
Okay.
there's no, you try them both, so.
You train us by using the secondary, right?
The secondary is easier because secondaries gives you a better image, and you can use it with a faster scan. Where the backscatter looks, you need a slower scan, otherwise it's too noisy. So, but it's what's nice is sometimes you can focus and stigmate with the secondary and then switch to backscatter, and then do a slow scan.
So if you're looking at the same material,
Yeah.
but different densities, like let's say you're looking at a porous material, one is more dense, one is less dense.
So you can kind of see, so this is secondary, and I'm seeing more of the features, right?
Right.
But because this is the same material, I don't really see like the scratches, right?
Oh, okay.
I see more of the,
Yeah, secondary.
yes, yeah. So it depends, you're right. If you're trying to look at like a fracture or something, then secondary. If you're looking at dissimilar materials, maybe backscatter is better. And then you can actually combine signals. So you can combine the two signals like 50-50 as well, secondary and backscatter. So the secondary, like I said, it's easier. If I went to backscatter, it's okay. It's a little noisier, but I just slow down the scan, right? All right. Any questions so far? I've kind of gone over the operation. Like I said, I know you're not going to remember everything until you sit down and actually start to use it yourself. So what's nice though, I'll show you, if you hover the mouse over anything, it brings up a little box to tell you what that does. So if you just let it, it'll tell you what that does. And then if I right click on any of these boxes, it brings up more detail, okay? So if you want to change, you can actually change how much content. So we switched to variable pressure mode. You can see our current vacuum. So we could turn the beam on right now, and we'll do that. But you'll notice that the image is going to be really soft because it's still pretty poor vacuum. But this is a good example to show you as the vacuum gets better, the image is going to improve. Okay.
Use the program to can you do that?
And then freeze the screen. And then freeze the screen.
Is that the long?
Vacuum gets better, this image will also get better. So backscatter, and now I have UVD.
So with UVD, you won't be having, when you use it in high vacuum mode, you still not be getting the resolution that you would get with the secondary electron.
No, so UVD in the high vacuum mode, it doesn't give you a strongest signal. No, but so what happens is someone figured out gas that we're letting in the chamber right now. So secondaries are still coming off our sample. The secondaries interacts with that gas and produces ultraviolet light. So then we use this detector to give us a secondary image from that ultraviolet light. Who figured that out? I don't know, smarter than me. But so this is actually but the UV detector likes the slow scan because it is a more noisy signal. But you can see that's more of a secondary image. So backscatter. With this sample, you don't see much difference in backscatter and secondary, but certain samples you will. So we're at 55, almost to 40. You can see this image is a lot clearer, sharper than when we were at, 200. So that's UVD. So it just gives us the capability for secondary image, and before we didn't have that capability. So it's a nice function to have. So, this sample is conductive, so we're not really seeing any charging. But if we did see charging, all we would do is just change that slider. Very simple. And just wait for it to settle down. Right here.
Yeah, what does that mean?
That's changing our vacuum level.
Vacuum.
So that's changing that needle valve position and how much atmosphere gas we're leaking into the chamber. So, and then the gun is sealed off from the chamber. We have a very small differential pumping aperture at the very end of the objective lens. So that keeps the gases from migrating up into the column. That's how we differentiate the pressure. So very easy to use to switch back and forth from high vac to variable pressure.
So when we know that we have to, let's say you're trying to measure tissue temp, then we directly go to variable pressure.
Right. So the question is, if you know you're going to be doing variable pressure, you can start right there. But like I said earlier, you can deal with charging in the high vac mode. You could start with a lower kV, right? And then do a faster scan or use the CSS, charge suppression scan capture. So some samples you could, if you're at 5 kV, 3 kV, maybe it's not charging that much. Some samples, like plastic, no. Glass, no. You're going to have to put in VP mode just to start. But you can always start. It's like I said, it's very easy to switch back and forth. So that's the nice thing about it. You don't have to open anything. It's very easy to go.
So how does the variable pressure work to prevent charging?
So so how does variable pressure work to prevent charging was the question. So in high vacuum mode, when our beam hits our sample and there's not a path to ground. So if it's a conductive sample, there's a path to ground. If it's non-conductive, the beam hits, interacts, and it builds up a charge because that charge doesn't have anywhere to go in a vacuum. So it'll build up until it's big enough, and then you see a discharge. That's the flashing, the bright white you see on the screen. So once again, someone much smarter than me figured out if we introduce some gas, that helps to dissipate the charge. It gives it a path to ground. It gives it, it ionizes that gas so then it doesn't build up that charge. So, and, the more gas we put in, the more it dissipates, but then there's, like I said, a trade-off. It's also interacting with our electron beam. So that's why we want to minimize how much gas we're putting in there, just enough to dissipate the charging. So that pamphlet I showed you also I think describes how the variable pressure works as well. So okay. So kind of went over all the basic operation. I'm going to turn the beam off now, and I'll switch back to the high vac mode.